we are talking about events, and events in C# are a built-in way of essentially notifying that something happened. So we can think of it as notifications. Now, it's not really like notifications in your phone, right? It's a little bit more primitive than that, right? We, of course, notifications evoke pictures of, little red dots with like exclamation mark, and like little animations and stuff, right? But that's not what we're talking about. We're basically talking about there's an object A, and something happens in object A, and object B, and object C, and object D, and so on, they want to be notified. And A wants to tell this to all of these, right? Now, the naive way of doing this would be that inside of A, you have basically a list, or you have some kind of reference of all the things that want to be notified. So A needs to know about B, about C, and about D, right? So then we have B, C, and D here. And you need to get these references somehow, right? So somehow, somewhere, you need to be like, hey, take this reference, put it there, take that reference, put it there, take that reference, put it there. And if you want to like destroy one of these objects, or if you want to add more objects or remove them or change them or whatever, you always need to change A as well. And this can create a uncomfortable position for us as programmers when we are designing our code. Because basically what you have here is a one-to-many dependency. You have a one-to-many situation where A needs to know about many things, A, B, C, A needs to know about B, C, and D, where what we would like is for a many-to-one dependency structure. Many-to-one. We also call this a dependency inversion. And you might know this from some of the programming principles that we have looked at. This is slightly different from like the solid principle, the dependency inversion principle, but it is similar. It goes sort of in the same way. So actually what we want to do is that we have a B, a C, and then D, and they depend on A. And actually what the dependency inversion principle states is that actually they should not depend on A, but rather on some kind of like A interface, right? And then that goes to A. What this means is that if you want later, you can remove this A and swap it for like a Z or something. And these don't have to change because as long as Z implements that interface, these don't care, right? Like these only see the interface. They don't care what is actually behind the interface. Okay, but that's besides the point for now. We can simplify it like this. They all reference A. Why is this better than that? If you were to change something, let's say, if I needed to add another thing, right? I need to change A. So let's say that A has some kind of list, right? Like just like we did it before. I can just reuse this. Let's say that I want to add another, like an E. I need to go here to my A and I need to add the E. And this seems simple in this example, but this can actually be very complicated sometimes. Because who knows where this E comes from, right? You have your object A, and then at some point you instantiate an E, and you know, it's maybe like deep inside layers of abstraction, and it's in a different part of your program, and you need to somehow link this two, right? Now, the linking part is not actually the problem. Like, you still need to link it here. Like, you will not get around the problem of linking things, right? So if I have an E here, I need to link them. But if I have an E here, I need to link them as well. The problem is that when you have this kind of thing, any of these that changes, you need to go into the A. You need to basically change two things at once, right? Whereas if any of these changes, this does not have to change, right? So if here I would change B, let's say I want to remove B and I want to put I don't know, an H there. I need to replace this, and then I also need to change the A to point to the H or something. If I do it here, I don't need to do anything to the A. I just take out the B, I place an H, and I just link it to the A, right? So this is basically also the same as doing like changing the A here. Like here, in this case, if I change just the A, these don't care, right? Like, so basically, when we have this kind of arrow that goes to the right, when I change what's on the right, I also need to change what's on the left, right? But if I change what's on the left, I don't need to change what's on the right. So basically, we want to put as many things on the left as possible, because if I change them, then I don't have to change what's on the right, right? We can think of this like that, right? Like, if I change this on the left, I don't need to change what's on the right. So yeah, that's the general idea. Okay, so that's the basic explanation of an event and why we want it. Now, where do we actually use it? One very common example is in GUI, right? And we will talk more about GUI, and we will do stuff with GUI in the future. But basically, you can imagine that we want to have a system where you have like your internal representation. So you have like your actual data, and then you have the visuals. And you want them to be separated somewhat, right? You want to have some kind of barrier between them. And so you have like your numbers here, right? Like your numbers and you know, strings and whatever it is, right? You have some values here. And in your visuals, you have your, you know, like your bars. So you might have like a health bar or something. You have your buttons. You have sliders, whatever it is, right? And the thing is, these things don't always translate directly to these things, right? So you need some kind of layer in between. And on the other hand, the data should not care how it is represented, because what actually happens quite often is that you have some data that is represented in multiple ways, right? So you might have data that is represented as text and as an icon or as a slider, right? Or we could add more stuff here, right? Slider, or as a color, for instance. So for instance, like you take your HP, right? Like let's say you have your HP value, and you can say, okay, write the text on screen, right? Like how much HP do you have? Let's say that we have 10 out of 100 HP. So we can just write that. We can just write 10 out of 100 as text, right? So this is a string. We can also make the health bar red or something because we are on low HP, or we make it blink or something, right? Like HP bar red. And icon, right? We can use some kind of icon to represent that we are on low HP. So we can use like a heart. And we can have a slider. So we can have like the actual HP bar, let's say, which is in a way it's like a slider, right? It slides left and right, basically. So I can fill the bar or fill it more or less, right? I can fill it all the way up, but if it's like, if I have like 10%, then, you know, there will be like just this kind of thing. So I'm representing the same actual data in different ways. Now, what do we have here? Look, we have this in this way that I'm representing it. So what does this mean? This, in code, we would represent this as something like we have our health class or our health whatever, right? Function, doesn't matter. And we have here some like HP or some kind of function. Let's just do it a function like that. And then we would do something like, text equals, you know, 10. I'm just simplifying here, right? And then I would say like, oh, color equals, you know, red would be 100, right? It's for RGB. And then the icon, we would need to say, oh, you know, icons dot heart, or, you know, whatever it is. And so on, right? So this is that one-to-many relationship, right? This is a one-to-many relationship. If I change any of these, like let's say, okay, I want, now my text component changed because I'm using like a framework or a library or whatever. Oh, now I need to change it here. Or I don't want the text to be like this anymore, so I need to change it here. Or, oh, the color format is different now. Or, oh, I changed the icons. It's not called heart anymore, or I don't have a heart anymore. Or even worse would be if I would need to like resize the icon. Like if I would need to do stuff like icon dot width, you know, equals blah 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 and stuff like this. Like, this is not the job of the health class. This is really not, right? Remember, SRP, single responsibility principle. This is not the job of the health class. So how do we solve this problem? We solve it by having an event. So we have our health function or class or whatever. And then all we do is we have a health changed event or something like this, right? Oh, I cannot, right? We have some kind of health changed event, right? So I'm going to write here, this is an event. And now what we have is like a text component. We have some text component. We have a color component. We have a icon component. And what they will do is they will listen to this event. So they will get a notification. Remember, events are notifications. So they will get notified, like you get notified on your phone. You know, they get like a push notification on their phone, right? And so then they will say, okay, you get notified by that, or you get notified by that. And then you have something like, okay, the text equals 10 divided by 100, or, you know, whatever it is. And actually, then we have the dependency structure like that, right? So then we go like color equals blah, 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 and the icon equals blah, blah, blah. And then we can also say the icon dot width equals blah, 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 right? Like, so then we can basically react to things that happened in the health class or in the health function or whatever. So we establish this many-to-one relationship. Okay. Now, this is a broader topic in software design. This is part of something called the observer pattern. And I will just go over this very quickly. The observer pattern is a way of implementing these kind of notifications. You have a observer, and you have the observed, but often is called the subject. Right? And now the subject is like something happens in the subject, right? So this is like a separation here. And when this something happens, the observer gets notified and then it reacts. Right? It reacts to something happening in the subject. So the advantage of this is that the subject does not know who the observers are, and it does not care. Right? It's like a TV show or something, or like a stream or a YouTube video or whatever. Right? It's just there. It's happening, and you can tune in. You can just watch. You can observe it. Right? But like the the person who creates the TV show or the radio show or the stream or whatever doesn't need to know who all the people are, all the people who are watching, right? Imagine the other way around, like you're a Twitch streamer and you want to broadcast to people. You would need to know their address, like you would need to know their like IP or something, and then you would need to send the video to them. That doesn't make any sense, right? Like it makes sense to have the opposite, right? You are streaming, you're the streamer here. You are just outputting your stuff to the internet, and then people can tune in. They come to you, and not you to them. And you don't need to know who they are. You don't know their names. You don't know where they are, their IP, or which operating system they're using, which type of machine they're using. They can be on a phone, on a TV, on a computer, on a PlayStation 5. Doesn't matter, right? So that's exactly the same thing with the observer pattern. Now, the observer pattern, it can be implemented in many different ways. It can be implemented in a sort of object-oriented way where you have a subject object and observer object, and then you pass interfaces around, like they implement interfaces and blah blah blah, and you have like this inheritance thing, and this is fine. A lot of people, a lot of frameworks use this, but there's another way to implement it, which is the way that C# implements it, which is with an event system, which is based on delegates. So we know that delegates are function pointers, right? If you don't know what delegates are, then you should watch the delegates video first. And basically, what C# does with events is that an event is a list of delegates or a list of functions. So it's basically just like a delegate list or an array or whatever. And what happens is you can basically, you as the observer, you add a function to that list, right? So here there's a list. Your function, your observer adds itself to the list, right? So add here plus a or something. Then when this something happens, what the event is going to do is just going to go through the list and call all the functions. It calls the a, and this function is a function in the observer. Okay. So might sound a little bit confusing, but I think it will become clear once we go into the code, which is here. So basically, we want to have a thing that reacts to another thing. So let's just make a very simple example here. We will make the example of the health. So I will say I have my health class and I have my text class. Okay, so in my health class, I will have essentially a list of delegates, right? So I will have a list, and let's say that my delegates are of type action, and because my health will be an int, right? I want my health to be an int. I will make an action int. Okay. So this will be my delegate list. I'll just initialize it. New list, blah, blah, blah. Okay. Now I will make a public void add listener, or you could also say add observer, right? So it doesn't really matter. In some frameworks or in some places you see the word observer, in others you see the word like listener, because you can also use this metaphor of like the Twitch streamer or like the radio show, you know, like you are listening to the broadcast, right? You're listening in. Let's just go with add observer. We add the observer, and this will be an action int function. And then all that we're going to say is say delegate list dot add function, right? And of course we can make a remove, right? Like we can do a void remove observer action int function, and then we say delegate list dot remove function. Right, just so all our bases are covered. And now what will happen here is I'm going to say public void change health. And there will be here like a, not modifier, but change something. And I also need a private int current health, right? And then I will say current health plus equals change. Okay, so I will be able to do this from the outside. I will just go here and I will do exactly that. I will say health equals new health. And you can think of this as like a Unity, component or something, right? Like you have your health component in Unity, which of course you don't need to do a new. You just can like do a get component or assign it in the editor or whatever, right? But this is just to keep it simple here, not fiddle with Unity stuff. And I will just say, okay, health dot change health, and I will, I don't know, add 10 health or something. Okay, so now let's imagine that we have some kind of UI component or some kind of UI text, right? And we want this UI text to react to that change in health. If we had a one-to-many relationship, right? That's the kind of relationship we don't want, right? If we had this kind of relationship here, then what we would do is we would have the reference to that text, right? Like text, and then you would need to go here and do like text dot blah, blah, blah. And you see how this gets complicated in code, right? Here it doesn't seem so bad, but then it gets bad here because like, okay, now you need to have all these variables for all these different types, and you need to pass this data to all of them and stuff like that, right? Or you have some kind of list, and then you need to have interfaces and base classes and virtual stuff, right? And it just gets messy. So instead of doing that, what we will do is in our texts, we will subscribe or add ourselves as an observer to this class, right? So we just do something like this. We can do it in the constructor. So I'll just pass the health into the constructor, like that. And then I will say health dot add observer. And now I need to pass a function, right? So my function will be a private void on health changed, and I will be like here, go like amount, or not amount, but like current health, because this is what I'm going to pass. And I just pass this function as a delegate, right? As an action, I pass this function to this other function there, and all it's going to do is take this function and add it to the list. Now, I'm going to just go here and say console.writeLine and the current health. And now in our change health, all that is left to do here is to call this function that we added. So I'm just going to iterate over the list. I'm going to go like for each func in delegate list, and I'm going to say func, I call it, or func, I call it, and you see here, it also shows me in the tooltip that I need to pass an int, and I'm going to pass the current health. So basically, whenever I change the health, I'm going to loop through all these functions that are in the list. I'm going to call each of them, and you see I can call them like this. This could also be a for loop, right? No problem at all, right? Let me show you a for loop here. I can do this, or I can also do this, right? I can just do that, no problem at all, right? So I just go through the list, I go through each of them, and I call that function, and I pass this parameter. Now notice that it's very important here, and you should already know this from the delegates video. It's very important that they all implement this signature. That's if they wouldn't implement this signature with returning or with taking an int as a parameter, then we would get a compile error precisely because of this. Because if this function did not take an int, then this would be an error. Like, the reason that I can do this is because I know for sure that they all take an int as a parameter, right? Because it's enforced by the compiler. Okay, so let's do this. I need to instantiate a text equals new text, and in the constructor I will pass this health. And then I will say, I will change the health by 1, let's say, right? So first the health will be 10. Then I create the text, and then it will subscribe. Then it will subscribe to the event, okay? And then I change it by 1, so then the health will be 11. And at that point, we should see it being written. Let's just check what happens. 11, okay? So I will do the following. I will set a breakpoint here, just so we see what's happening as it's happening. I go in, I set the health to be 10. I go through the list, but the count is 0 because there is nothing subscribed to the list yet. Now I create my text. I go in, I add this function. So I add observer, add the function, right? So it goes here, the function is there, and we see even like it's called method on health change, blah, 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 blah. And we also see here, look, there's the method PTR, that's the method pointer, also called the function pointer, right? Like, here's the actual memory address of our function. We go in here, we add it to the list. Now my list has a count of 1 because it has 1 element. We keep going. Now we do this change health. We change the health by 1. So now it's 11. We go through the list. There is something. And then we call that function, and that jumps then to the onHealthChanged function. Boom, there we are. And we just printed 11 to the console. There it is. Okay, so that's the basis of an event system. Now, the thing that we would like to do here as well is to not have this sort of mess in our health class, right? Because basically these three things, they don't really belong to the health class, right? They belong to the event. They are an event, right? So what can we do? Very easy. We could also make our own event class, right? And then we could put them here. Yeah. And then what we need to do is to make a function that I'm just going to call invoke. And I'm going to put this stuff up here. Right. Actually, we need to have something like this. Right. And now I need to have this this event. And then I have like actually it needs to be public event, health changed. And then I go here, health changed dot invoke current health. And now in my text, instead of going to the health.addObserver, I go health.event or changed, health changed dot addObserver, right? So I'm hiding this event basically inside of its own class that I can then reuse, right? And of course, what you can then do is make this generic. So I can make a T. And then I use the T here everywhere. Everywhere that I had an int before, I'm just going to go for T. So we get rid of all the ints and we make them all T. And now I can go event int. But if I have something else, right? Like if I have, let's say, I want to make it a float. I want to make my health a float, right? I want float. I want float. Now this is an error. No problem. Float. Boom. Now this is an error because I changed this to a float. No problem. Change this to a float. Well, again, here we see the magic of the generic types, right? So that's cool. But, well, this seems a little bit like a lot because there could be then other problems with events, but this would already work, right? Like this would already be like totally fine as an observer system. But the thing is, C# already provides this functionality by default without us needing to do all of this work. Yeah. So whereas you could do this and it would be fine, we can also just use the built-in events in C#, right? So I'm just going to comment this out for now and comment this out for now. And what I'm going to do is I'm going to say, let me comment everything out here. So what I will do is I will create a public event, and notice lowercase, and it's blue, so it's a keyword. I will use the same name, health changed. Oh, I need an action type, right? So I need like action float. Let's just go with float because I already changed everything to be floats. So basically, I have a variable of a certain delegate type. This needs to be a delegate, and I need to prefix it with the event keyword. Okay, so like this, I would declare a delegate. Like this, I create a delegate list, essentially, right? Like this is basically the same. We are doing the same as this. This event thing here had a delegate list inside, and this, by making it an event, I'm basically creating what is called a multicast delegate, basically a list of delegates. And now the way that I use it is very, very similar. I can go health changed. Now it is similar to a delegate. I can do this. Okay, and I need to pass a value current health. And this is very similar to a delegate. Okay. And then here I can go and do the following. health.health change. Now, instead of calling a function like add observer, I will simply use the plus equals operator on health changed. If I want to remove the function, I can use the minus operator. Okay. Whereas here, I would need to call remove observer, right? Like I would call this function to remove the delegate. If I want to remove it from an event, I can use the minus equals operator. Okay, so this would do the same at this point. Let me show you, except that we get a null reference exception. Okay, why do we get this null reference exception? The thing is, in this implementation that we did, we are basically going over the list here. So we iterate over delegate list.count, and this count will be 0, so we don't perform this, right? Because there is nothing inside of the list. So that's fine. The problem is that in the event, what happens is the following. It does not instantiate the list right away. Right, so here we are instantiating the list, and then the list is empty. But in the built-in event, we have basically this. So if we do this, the list will actually be empty. It is only initialized when we add the first one. So there will be something like this: delegate list equals new, right? So this is more like what the actual, like the built-in C# event is doing. And I can show you here real quick. This one. If we do this now, we'll also get a null reference exception. Why? Because when I call invoke, it goes to this list, and this list is null, right? I can call it again, put a breakpoint there. Oh, why don't I get the thing there? Oh, I need to, actually the error I'm getting now is different. I need to do this equals new there. Yeah, now we get the error there, right? Because the delegate list is null, right? We did not create the list yet, because we will only create the list when we add the first observer, okay? And this now mimics much more closely what the C# event is doing. And that's why we get a null ref if there is no observer, right? So let me just uncomment everything. Again, I will show you. We run this, and now we get a null reference exception here, and we cannot really see, we can't really see into the event code, but I can tell you that that's the reason why. Here it shows me even that the health changed is null, right? And that's because this is just a compiler trick. It shows me that the health change is null to represent that the health changed has no listeners, okay? So, okay. So what can we do? We can do the following. We can null check, right? If health changed is not null, then we can call it, okay? So let's try that again. Now we get the 11. And just to show you that it's actually working, let's add like 20 now. So now we should see 30. Boom, 30. Okay. Now, when we created this, there is a reason why I chose the word invoke for the function name. The reason is that the event actually has also an invoke function. And this is the same as doing this, basically, right? Like we can just do this or that. They do exactly the same thing. Let me show you. This still works. But if we use invoke, then we can do a neat thing. It's basically a neat thing, really, which is that we can do the null check all in one line. So we can do this dot invoke. What does this do? The question mark basically performs a null check. And if this null check passes, so it checks if this object or if this reference is not null. If it is not null, right, so this, then it does the rest. Now this thing here, this is one operator, okay? This is not a question mark and a dot. This is the question mark dot operator, okay? Which basically performs a null check and then calls the function. Okay, so don't think that you can do this with everything. Unfortunately, we can't. We cannot use this sort of, we cannot use this question mark with everything and like with variables and stuff. We can only use it with function. So I cannot do something like this. For instance, I cannot do, let's say, health changed dot and then some kind of field. Actually, fields don't appear here, right? Like these are properties. Yeah. Whereas here I could have access to fields, even though there are no fields here that are available. But maybe something like this dot, right? Like here I could have access to a field, but I have to, if I do this, then, well, actually I can because it's this, whatever. Okay, so I can do this. This is called the null conditional operator. So it's basically does something under the condition that this is not null. And these two do the same thing, right? We will see that we don't get any errors, and we see the 30 being printed 2 times because we are invoking the event 2 times. Now, a little bit of terminology, just to finish this off. We call event when you subscribe to the event. So this is basically like adding the listener, right? When you subscribe, you provide an event handler. And when this event is invoked or raised, right? Raising an event is a very C# way of saying it. In many other languages, they would say invoke or fired. You fire the event. But in C# they use the invoke method, but then they call it raising an event. I don't know. When you invoke or raise an event, you call the event handler. So the event handler is this. This is the event handler. Okay. And that's it. So then you can unsubscribe from the event and subscribe. So this is a little bit of terminology. You subscribe to an event, you pass an event handler. When the event is invoked or raised, the event handler is called, and then you can unsubscribe from the event. Last but not least is about unsubscribing. Unsubscribing is very important because what could happen is that you have some kind of event, you subscribe to it, and then if you don't unsubscribe, but in this case, like if my text object is deleted for whatever reason, and I raise the event or I invoke the event, I will get an error because basically I have a null thing inside of my list, right? Like remember, there's a list of delegates. You destroy the observer, right? You destroy the text object, but if you do not remove it from the list, there will be a gap there. There will be like a null element, right? Like this thing then will be null. So obviously it would be pretty bad to have these errors when we have like a null thing that was destroyed. This is actually quite common in Unity because Unity will like destroy your game objects and stuff, and then they might still be subscribed to events. So it's always a good practice in Unity to add your desubscription to like an onDestroy method, right? So you have your like onDestroy, and then here you would do your desubscription like so. And of course, yeah, in this case, we would need to have a reference to the health component and so on, right? So let's just keep this for later, but this is a general good practice. Another thing that we can use in regards to subscribing and so on is to avoid duplicated subscriptions that could happen for whatever reason, right? For whatever reason, we could have a component, like a text component, that subscribes twice to the same event, and then it would react twice, which usually is not a big deal, but it could be. Is also a pattern that you will see quite often, which is that people always put an unsubscription before the subscription. So you see this kind of pattern. And this is fine because if the event does not have this function, then nothing will happen, right? It's like in the list, if you call list.remove and a certain object, if that object does not exist in the list, then it's simply ignored, right? Like nothing happens, you don't get any errors, because the list will basically look for this object inside of itself. It doesn't find it, okay, just return, just continues, right? So if this thing does not exist, that's fine. If it does exist, then it gets removed, and then you add it again, right? But this basically makes sure that if there is already like an instance of this function, that you don't add a second one, because you could add a second one. Like if I made this a plus, then I would add this twice, and if I run the program now, I get this 4 times because I'm invoking the event twice, right? So now I get it twice. If I just do it once, either with the minus or not, doesn't matter, I will just see the 30 one time, right? So here, one time, and this does not change anything, right? And last but not least, it's the order in which things are added and called. Yeah, when you invoke the event, the functions will be called in the order that they were subscribed, right? So if you have like, you add method 1, then you add method 2, then you add method 3, they will be also invoked in that order. Okay, I think that's all. See you next time.